Today we're going to talk about binomials. What is binomial and what in the world is binomial expansions? So binomials, since we don't have that much time, we will break it down to the formula, which is a plus b to the power n, which when expanded is ncr. R is the number of terms. N, okay, that R looks weird though. Wait, hold on, let me fix that. R. NCR, where n is the exponent that is being raised to, and R is the number of terms by a to the power n minus r multiplied by b to the power of n. We can start with the basic binomial expansion. Say, let's expand a 3. Okay, no, let's expand something more simple to start with, something like 3 plus x to the power, let's say, something more simple, like x to the power, like cube, like this. And we don't know what we're going to do. Um, what should I do? How should I do? Well, we just apply the binomial expansion. So we write it as 3, that's our n, c, 1. Before that, we write an important part, one part I actually missed, is that when you begin the expansion, you start with, hold on, start with a to the power n plus this part, alright? Okay, now, we start with 3 to the power 3 plus, then we do NCR, which is 3c1, 3 to the power of 3 minus 1 multiplied by x to the power of 1. Now we continue incrementing once, 3c2, and so on and so forth. When you apply this in the calculator to use it, if you forgot how to find this value, you first type in 3, then click on the shift button in your calculator, then click on the division sign button to get this C sign. Then you write your smaller r value, let's say 3, then shift division, which comes to C, then 1, and what value you get, you do the multiplication. And this continues until you solve. Right, now let's talk about individual specific terms. Let's say we want to find a specific term in an expansion, like 3x plus, okay, no, we should not start something hard, that's too hard. Something like, I don't know, 4 plus 5x to the power of 70. And you're told to find let's say the 50th term. You're not gonna expand 50 terms to find it. So an important thing, when someone says to find the 50th term, it means we're also counting that a to the power n, meaning we're not actually taking in x to the power 50, we're actually taking in the one below that. We're taking in x to the power 49. This is because we are also including this, alright? We considered this as term 1 and this as term 2. Please, do not confuse this. Do not confuse that when it says 50th term, it does not mean x to the power 50. It's always going to be the one before that. So we're asking for x to the power of 49. So let's solve it. To find the specific term, we use the exact same formula. We know that the first part is 70 CR x, not x, is it x? No, it's 4, my bad. It's 4 to the power of 70 minus r, alright, okay, multiplied by 5x to the power of r. Here, we only take in the x variable, right? We'll talk about why we are only taking this and why it's important to consider. A little life hack, when you're doing this, ignore any constants. Ignore every single constant you see here, ignore it completely. You only take in the x variable, alright? We're just saying that to find the exact terms for, we want to find the 50th term, we take it as x to the power of r is equals to x to the power of 49. And we just use basic indices, not indices, I think index or something like that. I don't remember. You already know what it's going to be. It's always 49. Now, we just input in 49 in here. You might think, well, there's actually a little thing. Why didn't we just input the 49 before? You might wonder, wow, this feels hard. Is there a way? Is there a shortcut? Here's another shortcut. This is only applicable. I'm saying this. This is only applicable if, I'm saying this again, if the variable is only there once. See this variable? See, notice how it's, okay, let's make this highlighted. See the variable is x. See how it's only here once? You can use a little technique where you can just put in the term. 50th term, put in term 49. You're gonna get the exact same shit. And that's only because there's this x variable is mentioned once. But there is a catch. Say we have something like 3x plus 1 over 3x squared to the power of 7. And you are told to find the 50th term. We, of course, find x to the power of 49, because we're also including the first one, which is 3x to the power of 70 and whatnot. So what we do now is we find the 49th term. So we find 70 CR 3x to the power 70 minus r, then 1 over 3 by x squared to the power r. Alright, now here's a little trick for you guys. When you're told to find specific r values, ignore this, ignore this, ignore this, ignore this, ignore this. This is all you have. I'm pretty sure, I am pretty sure you know how this works. I'm pretty sure you very much know how this works, and how, by indice rule, we're actually just getting 2r is equals to x to the power of 49. Now we just find what r is equals to, right? So minus 2r is equals to, say, let's say 49 minus 70. We get something like 21 minus whatnot. So here's an important thing. Here's a little funny little thing. If you notice that the r is a fraction, it means it doesn't exist. R's can never be a fraction, alright? So in this question, I made a slight mistake. X to the power 49 does not exist. Does not exist, alright? It does not exist. Another important one is independent term of x. Independent term of x's, which basically means that there's no x variable in the middle of an expansion, in which case we're just taking that as x to the power 0. We're just only going to put here x to the power 0 in this r part, and we get the exact same result. Right. That's basically it. There's no other extra parts. Now, as for important maths, alright, boys, it's time to note some stuff down. We gotta note this down fast. We're going to 11, chapter number 11. What you wanna do is, I recommend this, from chapter 11, do every single example math. Alright, do every single example math. Okay? Doesn't matter which one it is, do every single one of them. From 11b, you want to do from 7 to 14, alright? Number 16, this is a must. Please do number 16, it's a must. And from review problems, it's pretty much up to you which one you want to do, but don't get too disheartened if you don't know what's going on. And also, please, whatever you do, if you're doing review problems, skip number 19. It is an absolute bullshit math. Anyways, that's all for today. That's all for binomials. There's no other extra part I have to teach. If I missed something, let me think. Oh no, I did miss something. I completely forgot about the most important part. Wait, we're not done. We still have unknown powers. In that case, we break down our NCR value. And NCR, C is actually choose, and it's basically the combination formula. But we don't talk about that yet. We learn that later. So, let's say we're given A plus B to the power of n. We have this written down. I think we have written down. Basically, first we have A to the power n, alright? Then, instead of writing NCR, we write n by 1 factorial. Then is the same as we did before. Now, an important part for you to know is that this, when we get to NC2, it's 2 factorial. But what's going to be on top? N multiplied by n minus 1. What about NC3? That's 3 factorial multiplied by n minus 1 by n minus 2. If it's 4 factorial, or NC4, then it's n by n minus 1, n minus 2, and then by n minus 3. It's the same thing and it's just going to continue up until infinity, whatever expansion you're doing. This is helpful when you don't know a specific power of a variable, right? So that's pretty much it. I don't think I have any other extra topics. So yeah, keep studying, and I hope you guys get an A star. If not, you're a dumbass.